Good morning, good afternoon, everyone. This is Ashwin Nayak. I'm the VP of Engineering at Zaloni. Welcome to Zaloni's DataOps virtual event. And today's event, we are going to share our perspective about DataOps, MLOps, how they are different or similar, and if they're similar, where it is similar. So these are all the point of view that what we practice, and we would like to share that with you all. If you think about from all the three ops that has been widely popular these days, it's all started from the success of DevOps and engineering discipline that's required for DevOps that has enabled a lot more faster development, execution, and agility for development and product development. And similar concept, engineering discipline, has been applied to the data, how the data comes in, how it needs to be orchestrated. And the same principle also applies to business intelligence and machine learning applications. Now, while we are this segment is all about data and ML, machine learning, but without the business intelligence and operational aspect of the BI, machine learning is incomplete, because every analysis, it starts with descriptive analytics, which is all about business intelligence in terms of defining what is the data tells the story today, what has happened in the past, before talking about the predictive analytics. So that's why we thought it's all the data, BI, and ML that has to come together to make the data leaders successful, and they are able to provide or accelerate the delivery of the trusted data to the organization and bringing the analytics insight to improve the performance. So let's focus a minute or so to how these three categories are similar. Now, where the DataOps comes in the picture to bring in the data to provide a clean data asset to the business intelligence. They leverage the data asset to create the data product. And machine learning leverages the same data asset to bring the score and insights. Now, the development aspect of all the three can happen in a separate tools and by a different set of skill set. Whereas where it is really common is to make sure how the data is being used and being delivered to an endpoint is all the metadata has to come together into the DataOps to provide a lot more intelligence around the consumption of the data, as well as provide governance capabilities. So, and the operational aspect and productionization aspect of all the three categories are being leveraged from the engineering discipline, making sure that change management, all the changes to the new model, changes to the new logical model of the BI, they're part of the CI/CD pipeline. So that's how the data, BI, and ML come together, yet the development aspect of it can be done in a separate tools. We also wanted to give you a preview of how they are interconnected in terms of the providing a comprehensive view. And if they are if you look at the tool, then they are separate. But unless you look into that as a code, that any of this application that are producing the data can be automated through the code. And that's essentially how the DevOps came to the life and solved quite a few of the agility problem. So when it comes to the DataOps, the function of that is really to it enable cataloging multiple data sources within very short amount of time, and providing the quality and classification and making sure that personal information is masked. And that exercise of data analysis is a function of data analyst, which is the beginning of any transformation project, or it's the beginning of any the data platform development. Now, if you're thinking about a pretty big data platform, project and it has 30, 50, 100 different sources, that step itself, the business analysis step, could take months. And everything is manual in a traditional way. But it doesn't have to be that way. With the DataOps tool, you have the connectivity to multiple tools at your fingertips, whether it's database, whether it's SaaS application, whether it's in a big data system. And you connect there, look at the data as a table without even bringing in the data into your platform, and run the profile to see what this data tells you, the story, and also run the data quality on the top of the data to say, here is, and then provide a sort of a mapping that has here are all the data sources, how it needs to be mapped, what quality rules that need to be applied, and provide that as a document, as a lineage view to the engineers for them to take that and build that in the pipeline. Every engineer would absolutely appreciate that level of clarity. And engineers, from the next step would be to build a logical model and physical model to hydrate the physical model. And the physical model is really important step. It's almost a foundational, fundamental block to the BI and machine learning use cases. Now, most of the time people talk about model, and they always, most of the cases, relates to the machine learning model. And very rarely people talk about the data model, which is something that I mentioned is a foundational element of your data asset. Then it gets into the BI. The BI analyst or report developer builds off of that the physical data model. Most of the BI tool has a plugin to the underlying database that create the KPIs and the drag and drop features where users can just drag and drop and automatically the SQL will generate, and then gets into the more machine learning use cases. Now, machine learning use cases doesn't have to be linear to BI, but it's can happen to parallel to some degree, but shouldn't happen before the data model is ready. Otherwise, you end up doing a lot of data wrangling problem in the machine learning itself, which creates a lot of inefficiency. So one of the first step of the machine learning is to create a feature engineering to format the data that is compatible to the machine learning algorithm. Now that step can be, some of it, repetitive stuff can be moved into data model at some point, but if it takes 80% of the complexity of the data into data model, the remaining 20% to put it into machine learning is perfectly okay, because you really, if you try to solve that problem in the very beginning, then you end up spending a lot of time, and by the time business moves on, and nobody really would get a value of your machine learning use cases. So that's why feature engineering is important to format the data. And then the next step happens is model development and training and validation, and really creating some of the data assets as a feature store, so that the feature store data stores the available data points for machine learning to serve at the edge, so that it doesn't have to query and retraining the model. So those are the elements of the machine learning feature development. All the three elements, each of the BI or machine learning have their own metadata system that can be brought into the DataOps tool, so that you have a centralized metadata, all the integrating the entities that's being used by BI and machine learning applications at entity level to create a comprehensive lineage view that has all about your data at entity level, attribute level, the business KPIs, derived attributes, and the models, and which models are used in production, what's the number of experiments. Those are all the part of the observability. Comprehensive observability is the fundamental block of, or fundamental feature of the DataOps tool. And in our view, we take the approach of DevOps. It touches to all the three. It has solved the problem of CI/CD from a development standpoint, and we are seeing more and more. We are getting into the BI changes to the pipeline of the DevOps. And so as when the machine learning models are ready, integrating that from MLOps standpoint into our CI/CD process, so that those changes goes into DevOps tool, gets into the higher environment, and then the training can happen for all the machine learning models as the new data comes in. So instead of from a CI/CD DevOps, it's now transitioning to CI/CD and CT. T stands for training for all the three blocks of the data, where it is created and consumed. So we just wanted to, and this is how it is integrated across the three. Okay. We also wanted to share with you a simple example of how the data format changes from one system to another, and what are the type of metadata that can be leveraged or can be captured. So let's take an example of in a bank trying to predict which customers will default their mortgage payment. So the type of data they would need is a customer account, the bill payment, mortgage payment transactions. So all those data elements or the tables would be in a data model. They're hydrated, they're validated. That's part of the DataOps. And that same data model is now converted into a schema that is more friendly or to the BI tools that what your organization use. And their standard BI schema would be you have a customer dimension, an account, and you'll have a set of lookup tables, and the KPIs you'll build based on what business users have provided the requirement. And in business users, they drag and drop attribute and metrics, and the SQL gets generated behind the scene. They don't have to write a line of SQL, so which is perfectly, which is great. Then when it comes to machine learning, the feature engineering that happens with encoding the variable and making each entity, whether it's customer and account, as a more of a flattened structure, and calculating the variable through encoding, through binning, through imputed, so that the algorithm looks into that right type of data while it's doing this during the prediction model. And then when it gets to the model development validation, you take that into more of an experiments. How many experiments that you run with a different algorithm, which one gets a better result. Now, this doesn't happen in silo. This function with the resources that's running on machine learning development and validation works with the business users, or has to work with the business users in a very collaborative way to understand their business need. They're showing the result and taking the result feedback and improving those things. And that is an experimental time they go through that exercise. And that's when they decide how that model is supposed to serve in a production setting to finalize the feature store requirement. So that's the sort of a functional way of how data BI and machine learning works, and how the data format, the same type data, but it's different format that gets created across the three areas. From a metadata standpoint, while the data is coming into the system and the analysis and orchestration is happening, a lot of rich metadata is already created. So whether it's an entity, what DQ rules, what business glossaries are available, what are who is the data owner, business owner, technical owner, and a lot of that rich metadata is already available. Now you're adding that another enrichment layer from BI metadata that has what are the KPIs that's created in the BI tools, what are the business rules for that, and what are the derived attributes our users have created in their report, and what's the runtime and how many times that particular entity is being used and which reports it's being used. And then from a machine learning standpoint, it goes a little bit deeper to say how many experiments has been run on that entity. What are those? What are the registered models, and what's the model history? Where the endpoints are being served, and who are all the users who are getting the access to these data sets and which tool. So I think that's bringing in this 3 metadata in one tool, in the DataOps observability tool, is very, very important, because now you can answer where the data is coming from, how it is being used, what is your risk of potentially that if are you meeting your compliance need, and if due to some reason, if you are sunsetting a system or you are acquiring another system, you're migrating another system, a lot of time is being spent how this data is being used, and that type of time can be streamlined, can be find the answer right away within having this in the DataOps tool, if you have done a integrated this system and or building it in the DataOps tool in a more systematic way. So we wanted to share this perspective with you, and hopefully this is helpful, kind of brings some life into how this data, BI, and ML work together, and how engineering discipline can be applied. And as you're making, as a data leader and making decisions, you want to make sure that you have one system that tracks across your spectrum of different tools that's available, so that you are able to provide your business users an agility and a way for them to answer the questions pretty quickly, that should have that at their fingertips. So thank you so much. Hopefully this was informative for all of you. Thank you.